operation that involves the use of a multiple tooth cutting moved linearly relative to the workpiece in the direction of the tool axis. The cutting tool is called broach and the machine tool is called broaching machine. Types of broaching. 1. Linear broaching. 2. Rotary broaching. Linear broaching. In linear broaching, which is the more common process, the broach is run linearly against a surface of the workpiece to effect cut. Linear broaches are used in a broaching machine. Rotary broaching. A rotary broach is used in a lathe and screw machine. Both processes the cut is performed in one pass of the broach, which makes it very efficient. Applications. Broaching is used when precision machining is required, especially for odd shapes. Commonly machined surfaces include circular and non-circular holes, splines and keys, and flat surfaces. Typical workpieces include small to medium-sized castings, forgings, screw machine parts, and stampings. Basic principle of broaching. Broaching is a machining process for removal of a layer of material of desired width and depth, usually in one stroke by a slender rod or bar-type cutter having a series of cutting edges with gradually increased protrusion. In shaping, attaining full depth requires a number of strokes to remove the material in thin layers step by step by gradually infeeding single-point tool. Whereas broaching enables removing the whole material in one stroke only by the gradually rising teeth of the cutter called broach. The amount of tooth rise between the successive teeth of the broach is equivalent to the infeed given in shaping. Broaching operation. Broaching machine. Broaching operation. 1. Machining. Broaching is also accomplished through a series of following sequential steps. 2. Selection of broach and broaching machine. 5. Planning tool work motions. 4. Fixing workpiece. 3. Mounting and 2. Selection of broach. 1. Like any other machining. 1. Like any other machining, broaching is also accomplished through a series of following sequential steps. 2. Selection of broach and broaching machine. 3. Mounting and clamping the broach in the broaching machine. 4. Fixing workpiece and machine. 5. Planning tool work motions. 6. Selection of the levels of the process parameters and their setting. 7. Conducting machining with a broach. Selection of a broach and broaching machine. There are various types of broaches available. The propriation has to be selected based on 1. Type of the job size, shape and material. 2. Geometry and volume of work material to remove it from job. 3. Desire length of stroke and the broach. 4. Type of the broaching machine is available or to be used. Broaching machine has to be selected based on 1. The type, size and method of clamping of broach to be used. 2. Size, shape and material soft workpiece. 3. Strength, power and rigidity required for the broaching machine to provide the desired productivity and process capability. Characteristics of a broaching operation. The unique characteristics of broaching operation are: for producing any surface, the form of the tool, broach, always provides the generatrix and the cutting motion of the broach relative to the job surface, provides the directrix. So far as tool, work motions, broaching needs only one motion, and that is the cutting motion, velocity, preferably being imparted to the broach. Specification. Broaching machines are generally specified by O type, horizontal, vertical etc. O maximum stroke length, O maximum working force, pull or push, O maximum cutting velocity, possibly O power, O footprint. Classification of broaching machine. O according to the purpose of use, A. General purpose of single purpose Ec. Special purpose A. O according to the nature of work, A. Internal broaching. External, surface, broaching. O according to the number of sides or stat iona. Single station type Heb. Multiple station type Ec. Indexing type. Classification of broaching machine, continue. O according to the tool / work motion A. Intermittent, one job at a time, type Heb. Continuous type. Advantage of broaching. O very high production rate than milling, planing, boring etc. O high dimensional and form accuracy and surface finishing. O roughing, finishing in single stroke of same cutter once, only one motion, cutting. So design, construction, operation and control are simpler. O extremely suitable and economic for mass production. Limitations. O only through holes and surface can be machined. Usable only for light cuts. i.e. low chip load and unhard material, so cutting speed cannot be high. Defects or damages in the broach severely affect production quality. Design, manufacture and restoration of the broaches are difficult and expensive. A separate broach has to be procured and used whenever size, shape, and geometry of the job change, so economic only when the production volume is large.